Solving system of equations involving three unknowns. Suppose you were given 3x plus y plus 2z is 6, and x minus y plus 4z is 4, and 2x minus y minus 3z is negative 2. The steps are, you want to pick one equation and one variable. Using the equation from step 1, you want to eliminate the variable from step 1, the one variable you pick. You want to eliminate the variable from the other two equations. This gives us two equations with two unknowns. In other words, if you use the first equation to get rid of the z's in the other two equations, now you have two equations with two unknowns. Solve for the two unknowns. Using any equation with the third unknown, solve for this unknown using the knowledge of what the other two variables are, 4z and 3z. Now I notice that the numbers in front of y, excuse me, the number in front of 3z, the number in front of y are the same. I don't care about signs. The numbers in front of the y's are the same. I'm going to use equation 1. So step 1 says pick one equation and one variable. I'm going to pick equation 1 and their variable y. Okay. Number 2, using the equation from 1. That is, using equation 1. Eliminate the variable from the other two equations. If I just simply, I'm using equation 1, if I add 1 and 2 together, if I just add 3x plus x, 4x, y plus negative y is 0, that's why I added, 2z plus 4z is 6z equals 6 plus 4 is 10. Now, using equation 1, if I just add equation 3, it's a similar thing. 3x, plus 2x is 5x. Positive y plus negative y is 0. That's why I'm adding. 2z plus negative 3z is negative 1z. 6 plus negative 2 is 4. Step 3 says this gives us two equations with two unknowns. Here they are. Okay, now this is old-fashioned for us. This is the old style. The original technique we're going to use. Step 4 says solve for these two unknowns. Well, I like the fact that this is 1z. Since that's 6, z. I'll keep the first equation the way it is, and I'll multiply the second equation by 6. This times 6 is 30z minus 6z equals 24. Now I add. Why do I add? Because when you add those two, you get 0. This should be 34x, excuse me. 5x times 6 is 30x. 34x is equal to half, 34. A lot of people say, oh, you divide by 1 here. You divide by 34. You could, but just ask yourself. 34 times what gives you 34? I hope you realize it's 1. Now, go back to one of those two equations in this box here and solve for the other variable. I'll use the second equation. I know that 5 times x, and I know x is 1, minus z is 4. 5 minus some number is 4. We happen to call that number z, but you all know that 5 minus 1 is 4. So now we know z is 1. So I did step 4. I solved for the two unknowns. Step 5 says, using any equation with the third variable, x and z, we solve for, so we need to solve for y. Using any equation with the third unknown, that is y, solve for this unknown. Well, I'll use equation 1. I know that 3 times x plus y plus 2 z's, and z is 1, is equal to 6. Well, this is 3 plus y plus 2 is 6. Well, 3 plus 2 is 5. Y should be 1. 5 plus 1 is 6. So this tells me that y is 1. And I have my answer. X is 1, y is 1, and z is 1. You can plug it back in to make sure this is correct. Sure it is. Try another one. X plus 2y minus z is 2. 3x plus 2y plus 3z is 0. X minus y plus z is 0. Step 1 says pick a equation and a variable. Now, depending upon your skill level, you can be more intelligent about picking the variable and the equation. But if you're not really good at this, maybe always pick equation 1 and the first variable. First variable is x. Okay, but just pick one. Pick one equation. You have equation 1, 2, and 3. Pick a number. And then the variables are x, y, and z. Pick a variable. Okay, I'm going to use the first equation, and I'm going to get rid of the variable x in the other two. So I'm going to pick a variable, I'm going to pick equation 1, and the variable I'm going to use is x. Equation 1, 2, and 3. I hope that came out on the board. 1 and variable x. Now, let's get rid of the x in equation 3 first. X and x. X and x. Subtract. You can do 1 minus 3. You could have done 3 minus 1. But x minus x is history. Positive 2y minus negative y. 2y minus a negative y becomes 3y. Negative 1z minus an understood 1z, that's minus 2z. And 2 minus 0 is 2. So I got rid of, in equation 3, I got rid of x. And I used equation 1 to do so. Now, I'm going to get rid of x using equation, I'm going to get rid of x in equation 2. I'm basically going to do 3 times 1. Then I'm going to take away 2. Because if I triple the first equation, that is, I multiply it by 3, I'll get 3x. In the second equation, n plus 6y, etc. But in particular, I get 3x. The second equation is not being changed. Nice. Now, if I subtract 3x, minus 3x, that's history, it's 0. 6y minus 2y is 4y. And you all know that 3 minus 3 is 0. But that's not 3z. It's negative 3z. Minus 3 more z. That's minus 6z. Is equal to 6 minus 0, which is 6. Personally, I would divide this equation by 2. Make the number small over 2. So you have 2y minus 3z is equal to 3. Here are my 2 equations, 2 unknowns. You can solve this. So you pick one equation and one variable. And using that equation, you kill off that variable, you eliminate that variable from the other 2 equations. Now, in my 2 equations, 2 unknowns, the numbers in front of x, the number in front of the y's are different, numbers in front of the z's are different. There is 3 and 2 versus 2 and 3. The numbers in front of y from top to bottom are 3, 3, and 2. In front of z, they're 2 and 3. Doesn't matter which one we do. Let's get rid of y. The first common multiple between 3 and 2 is 6. Here are the first few numbers on the 3 times table. Here are the first few numbers on the 2 times table. I won't argue that 12 is a common multiple, but 6 is the least one. We multiply the first equation, this equation here, by 2, because 3 times 2 gives me 6. So I get 6y minus 4z is equal to 4. We multiply this by 3, because 2y times 3 gives me 6y. Multiplying by 3. And then if I have 6y and 6y and I want to get 0, I subtract. A lot of teachers say, oh, don't subtract. You can subtract. It's not hard. Negative 4 minus a negative 9. Negative 4 minus a negative 9 is 5. 5z. 4, take away 9, negative 5. 5 times some number gives me negative 5. The number is negative 1. So now we have z. Z is negative 1. Let's get rid of the instruction. Z is the magic number, negative 1. So go back to the 2 equations, 2 unknowns. And with the knowledge of what z is, let's find y. I'll use the second equation. 2y minus 3 times z is 3. Negative 3 times negative 1 is positive 3. Some number, when I add 3 to it, gives me 3. Some number plus 3 equals 3. You all know it's 0, but many of you haven't been trained to think of that. It's 0. 2y is 0. 2 times y gives you the number 0. And the answer is 0. So now I have what y is. And I probably should have written that up in the top corner, but I didn't. Okay. So I ran out of room to write below, so I'm just going to write it up here. Go back to any equation that has, well, we have y and z. Go back to any equation that has x in it. Any equation. The easiest looking one. It's the one that I think I called 3. X minus y plus z is 0. X minus y is 0. Now plus z is just negative 1. 0. So x, you don't have to worry about taking away 0. X minus 1 is 0. Now, you know 1 minus 1 is 0. You know that like you know your name. The x is 1. The answer is, x is 1, y is 0, and z is negative 1. Okay, gave you the steps. The first thing you need to do is memorize the steps and understand what it is you need to do, and then practice doing it. But a lot of students will practice doing it, and maybe initially they're not good at it, and then they get really good and they never ever make a mistake, and then the test comes and they don't get it right. The reason is that they never learned the steps. They never memorized the steps. Yeah, sure, you have the steps in front of you when you're doing your homework assignment, and at some point you start getting them all right, but you never memorized the steps. You need to walk down the streets stating what the steps are between television commercials. You need to state what the steps are. You need to memorize the steps. You can't play the game if you don't know the rules. Okay, that completes this section. Actually, there's one other thing that we should talk about. There are things called inconsistent and dependent. Inconsistent, T, and dependent. Suppose you have an equation like this. Suppose you have x plus 3y plus z equal to 4, and you have x plus y minus z is equal to 5, and you have 2x plus 4z, make this 2z, 4y, excuse me, plus z is equal to 10. Now, it's going to turn out that this is independent. See, this is inconsistent. It's going to turn out that this is inconsistent. And how you might see this? If you add the first two rows, what you get is this. That is, this must equal 9 from the first two equations. But it's the solution here. There will not be a solution here. Okay? But how would you see this if you didn't see it right away? Well, you try to solve it. You pick an equation and the variable. I'm going to pick equation 1, and the variable I'm going to pick is x. So using equation 1, I'm going to get rid of x in equation 2 and 3. If I just do equation 1 minus equation 2, x minus x is 0. The x is gone. 3y, positive 3y minus y is 2y. 2z minus a negative z is 3z. And 4 minus 5 is negative 1. Now, to get rid of, and now I'm working on 2 and 3. I have to double equation 1. 2 times equation 1 is 2x plus 6y plus 4z is 8. And equation 3 is what I'm writing down. The nice thing is that's equation 3. If I subtract, this cancels out. 6y minus 4y is 2y. 4z minus z is 3z. 8 minus 10 is negative 2. So here are my 2 equations, 2 unknowns. Now you might see it here, the contradiction. 2y plus 3z, 2y plus 3z. Up here it equals negative 1, down here it equals something else. So that's the problem. Now, if you didn't see that, you have your 2 equations, and you have the 2 unknowns, and you say, oh, this is simple. I can get rid of y by subtracting. 2y minus 2y is 0, the y's are gone. Coincidentally, positive 3z minus positive 3z is 0. Negative 1 minus a negative 2 is 1. This is not true. This is nonsense. 0 does not equal negative 1. That is inconsistent. The system of equations that we were initially given, 3 equations, 3 unknowns, are said to be inconsistent. Okay? Whenever you get one number equals another number and it's not true, then it's inconsistent. But on the other hand, if we got 0 equals 0, then it would be then it would be dependent. Whenever you get 7 equals 9, inconsistent. But if you got 7 equals 7, it's dependent. You need to go into your exams knowing that. If you get one number equals another number, and it really aren't equal, 2 equals 9, you know 2 doesn't equal 9. Well, then that is said to be inconsistent. But if you got 9 equals 9, that's dependent. I'm going to change this 10 to a 9. I'm going to change it to a 9. And when I subtract the first 2 equations, I'm going to get 2y plus 3z is equal to negative 1, just like I did before. And if you double the first equation, that will give you 2y. 2x. The reason we want to double the first equation is because the third equation also has 2x. And I'll do subtraction. 6y minus 2y minus 4y, is 2y. And yeah, the 2x is canceled. 4z minus z is 3z. 8 minus 9 is negative 1. So that's the second equation. 2y plus 3z negative 1. If you try to solve this, once they're the same two equations, and they are, you can say dependent. But if you say, oh, I can get rid of y easily by subtracting. Oh, that also subtracts to 0. Oh, negative 1 minus negative 1 is 0. Oh yeah, one number equals a number, and it's true. That implies dependent. Inconsistent would be 7 equals 0. Dependent, 0 equals 0. This is not true, which means inconsistent. This is true, that means dependent. Dependent means is an infinite number of answers. But that's beyond the scope of this class. Inconsistent means there are no answers. Can't be solved. How can you solve something that implies 7 equals 0? Alright, good luck on this.